Hello and welcome to this series of short videos that have as goal to get you started as quickly as possible doing a layout of circuits by using KLayout as the editor for layout drawing and the Global Foundry GF 180 MCUD as the PDK for the underlying technology. The goal of this first video is to talk a little bit about the logistic of getting the tools set up and running. And so before I get started with this, I want to emphasize that I have opened my web browser here and I have three main tags. The first tag, I guess, it's on my GitHub, where in case you need a more detailed tutorial on how to set up the tools with Dockers, you have a link with more detailed instruction. And also the other thing that my GitHub is useful for is that I will post all the information related to the videos on this repository. Then we have the repository of the Johannes Kepler University, providing the infrastructure, the ecosystem for installing all the open source tools needed for designing integrated circuits. And finally, I have a third tag, which is providing you the documentation for the Global Foundry GF180 MCU PDK. And the main reason why at this point I decided to put this link there is because I want to stress out that it's extremely important that before you get started doing layout, you take a look at the design rule for the technology that you are using. You don't just go and start randomly drawing shapes and layers, but you should have a good understanding and good idea of what are the design rules that you need to follow for designing a working operational layout. Okay, so let's get started with the logistic of installing the tools. The only assumptions that I'm making in this video is that you have already downloaded and installed both Docker and VS Code. And if you have done so, start Docker. And if you start Docker, what you see at the moment is that Docker is running in the background, but there are no containers nor images that have been yet created. Then the next step we're gonna do is open VS Code. Go here on the top right of the window and click on this icon to start a terminal on our local machine. And then we go back to the IC OSIC tools link and go look at the documentation and copy the command for cloning the repository locally on our machine. So here you click on the copy, we go back on our VS Code terminal, we paste, and at this point, in a couple of seconds, the repository is going to be cloned locally. So at this point, we can traverse and go to the directory where the repository has been cloned. And if you go into this directory, there is actually a very useful script called start_x.sh that will allow you to create the IIC OSIC tools Docker and with all the default preferences that are needed to get everything up and running and working. So now, normally actually what I like to do instead of starting everything with the default is to slightly give a couple of personal preferences. And so what I usually do, I actually write a little wrapper around this script. I call this wrapper vi underscore sh. Vi stands for go in Italian, actually. And so in this little script that I'm gonna, in 1 second, gonna build, I'm gonna add to the start underscore dot sh a couple of extra line to basically customize a couple of variables that are useful. Okay, so to be a little bit faster here, I cheated a little bit and I have already created the script offline. So I'm going to open it and show you what's inside. So besides the important script that was provided already under the repository IIC OSIC tools, which is the start underscore dot sh script, I added two lines. One is defining this variable design, which is actually the variable that specifies where the user data is mounted on your local system. In my case, instead of using the default, I decided to put all my user data on my Google Drive. So that's what the first line does. And then the second line, you don't have to do that. You can perfectly use the default, especially if this is the first time you are running the tools. Then the second line, though, that you should run, which is important, is to add this variable docker underscore tag and set it to the 2025.09. This is actually basically specifying what version of the Docker we want to build. And it's important that you use the 2025.09 rather than the latest, because there is a couple of bugs that are, I guess, are not yet fixed. And so we need to use this 2025.09 version to make our layout, to draw our layout successfully. Okay, so at this point, all I have to do is for basically creating the Docker is to type source vi.sh, and that will start the process of creating the Docker. Now, this is gonna take actually quite a bit, so I am gonna pause the recording and restart it once the process is finished. So if everything goes as expected, after a while, you get this Windows terminal to pop up, and here you see that there has been a bunch of preferences that have taken place. Actually, let me show you a couple of things because I forgot to tell you something important. First, let me go back here into my local terminal and show you that all my user data is on my Google Drive. And so if I go here to my user home directory and I do an ls minus al g home, you're gonna see that I have actually created a link called ghome to my Google Drive. Okay, and then I also, so if I do cd ghome, it will bring me to this user Talarico ghome. And then what I wanted to show you is that the data has been mounted on my local machine in a directory called EDA design. And so you see here the path. That's where I have all my data, all my project, everything that have to do with the Docker data. So in particular, there is one thing that I was telling you I forgot to mention, is that the PDK, the Global Foundry PDK, is not the default PDK that gets started when you build a container. And so if you want to get it started as the default, you have to set up a few preferences. And these few preferences are actually into a file that it's called design init. Now, if you go to my website here, I have actually put my design init there so you can download it if you want to use it. What you see here there is that I basically have defined, again, similarly to what I have done in the wrapper, a bunch of variables so that the default PDK that we're gonna use it is the Global Foundry PDK, and then there is actually a couple of other variables that I have defined that have to do with my preferences in where to look for the spice initialization files for the sake, I guess, of this tutorial. That doesn't really matter because we're not gonna touch any spice. But then there is another important variable that you should put into your design init, and that is called your user designer. Okay, so if you want to have the same preferences and have the tools start exactly the way that they started for me, what you should do, you should download this design init file and change its name in .design init. Okay, so don't forget that you need to put ls minus la. Okay, so if you go and look here, there is a file called .design init. Don't forget to put the dot in front of it. Okay, perfect. So at this point, we have our terminal, the black window. Let me close here. Where is it? The black terminal window that popped up after we finished the process of building the Docker available. And you can totally start and work from within this terminal. In my case, I decided to put all the files that we're going to use it in the location that I am gonna type it. So all my files that we're gonna use it are there. And if I wanna start KLayout, all I have to do is say KLayout, and I have already the layout of an inverter ready. So if I do KLayout invgds, that will open KLayout in view mode, actually, on the layout of the inverter that I have built ahead of time. I guess it's gonna take a few seconds, but let's wait patiently and see that the KLayout starts. There it is, starting. Yes, this is the first time that I'm starting it, so it's a little bit slow. Later, everything will go into cache and things will be faster. Okay, so perfect. That is now the KLayout of my inverter. So one thing that is important, see here, the technology file is taking some default. Well, you don't want the default, you want the GF180, so click on it and then click it again. And now here, as you may have noticed, some of the colors changed, and here now you have like more layer definitions. Actually, typically, one thing that you should be doing is you should click this hide empty layers so that you see only the layers that have been used into the layout. And then if you expand here, you see that our layout of the inverter has been built by using a couple of macros. There is a macro for the NFET and there is a macro for the PFET transistor, so we don't have to build them all the time from scratch. In fact, if you go here and you click, you see that there is a library of what in jargon are called P cells. P cell stands for parametric cells, and here you have the cell of the NFET and the cell of the PFET, and we'll talk about all these details later. For now, all I really wanted to show you were the logistic of how to get the tools started and set up. Okay, so let me go and exit. So as I said, you can totally work from the terminal that popped up. If you love to work with VS Code because that's how you guys have taken all your computer science classes or so on. The other thing that we can do, we can click here on the open a remote window, and then you can attach your VS Code to the running container, and that will now link VS Code to the container. And hopefully this is also gonna be fast enough, since I promised you short videos. There we are. We got VS Code now opened on our container. So you see there, it opened on the FOSS Design GF 2025 ring. So this FOSS Design on the local machine really is my username, and then the link to the Google Drive. That's the physical location, and the other one is the logical location, how has been called by the Docker. So as I said, if you want to do everything from within VS Code, same story. So you can do KLayout inverter.gds, and that will start KLayout exactly the same way that we had it from the main terminal. Here we are, okay? And this time, since I have already set a few preferences and clicked a few things, it started already correctly on the technology file GF180 MCU. And here I have my parametric cells for the NFET and the PFET. And at this point, I'm gonna stop the video, and we'll talk more about how to do the layout in the next video.